Yes, it is recording.
Okay, so it will be available on YouTube itself.
Yes, I do not know where it will be available, but I will check on that and let you know. It should be available in YouTube.
Okay. Thanks a lot.
Sir, any book that you could suggest for exploring in the question in the chat?
I have personally been a fan of book by Robert Stein and Dean Foster. They are faculty members at Wharton, and very beautifully they have explained the applications of analytics to a lot of business functions. So that's one book that I will always recommend. And our good fortune is there are plenty of good books. So in absence of any particular book, don't stop your reading. Pick up anything, and that should do, right? But if I have to recommend one book, I mean, even Anderson's book, right? I mean, that has been around for so long, right? Anderson Sweeney, that textbook on business statistics has been around for so long. I mean, at that time we didn't have a term called analytics. It is that old, right? But it still remains relevant, very relevant, right? Dean Stein and Foster, the one that I earlier recommended, that book, the first edition came out in 2011. That means the book itself is about 10 years old, but obviously they have had several editions, right? I think they are right now in seventh or eighth edition. So many books.
Okay. So how to access the YouTube recordings? We do have a BSc online TV channel. That is where these recordings usually go into. So you will find it there. All right. Okay. Lavanya, the calendar does not show. Someone has said that it is not showing. So please go website and afterwards. If still you are feeling a problem, write to the support team and also put it in Discourse and tag me. I will do a follow up and get back. Okay. Which links, Bimlesh?
Which links are you talking about, Bimlesh? YouTube links.
No, in your calendar it should show. No? You should be having a link to live stream. So the calendar's live stream link will take you to YouTube where you can really watch it. Most probably the same links will have the recording. I do not know. I will confirm and get back to you. We shed some light on what issue we will be able to answer at the end of this course that industry face.
Yes, there is a session called Epilogue, which is a kind of a summary that we had recorded. Dr. Malalan will also remember, right? We had jointly recorded that session. So that summarizes what we had discussed and what to expect in industry and how the course may be relevant, right? One very simple thing that you have to remember. Many of these courses, right? Any academic course that you will credit anywhere will tell you that okay, let us solve a regression problem, and then we'll discuss how to read a regression output and how to interpret the economic sense out of it and all that, right? In real life, no problem comes to us as, oh, you know what, this is a regression problem. You know what, this is a classification problem. You know what, this is a market basket analysis problem. So the most fundamental skill that we have to build when we go to industry is to understand what is the best method to solve that problem. And first, okay, that is a wrong statement. We don't solve any problem, right? I mean, we answer some questions. So depending on what questions are posed, some methods become more appropriate than some other methods. For the same data set, if I ask different set of questions, the methods are different. So it all depends on what questions are you asking, right? And that's where business analytics is different than, I would say, data science. Data science focuses on the techniques. Business analytics should focus on what questions are you trying to answer here. right? Yes, but there is a session called epilogue towards the end.
Live stream links are not available for this live session. I believe that is because they are uploaded in YouTube channel, so you can go there and get it. So that is the reason that they are not given uh, post post the live session. I believe you can get it in the YouTube channel, but I will verify and get back. So will this course be?
Shashi has a question about math rigor. So every course, I think Dr. Malonan has heard this from me probably 10 times already. This is the 11th time. There was a British mathematician called Littlewood who used to say that theory without practice is useless, theory without any practice is useless, and practice without theory is dangerous. So we are going to focus on business applications. Yes, every session will have one business application covered. We will also cover the math of it, right? But the anchoring is on the business application. Doesn't mean that there is no math in it.
If I can give a disclaimer, I believe that question is coming after they have done the MLF or something of that sort, or statistics course. You will not find that much amount of math that you saw in a pure stats or math or MLF course. Here, the focus will be on the math of the technique and its application. So in that sense, it is different. The rigor is there, but not on the math part, but on the technique part. Okay. Do we have any other questions? You can also unmute and ask. Raise your hand and unmute and ask. Or you can post it in chat. In the meantime, sir, we had one question on the discourse where they wanted to know the difference between simulation and empirical distribution.
Okay, trace-driven and
Trace-driven simulation. Yeah.
Okay. In trace-driven simulation, so essentially we are building some statistical model using some input data, right? Now there are multiple ways that you can actually use this input data. The most basic thing you can do is don't worry about what that input data is, plug in that input data directly into your stat model or math model. That is what is called as trace-driven simulation. So you are not massaging the data, you are not building any distribution on top of the data and entering only the distributions as the input to the data to the model. You are actually plugging in direct raw data into the model that you have built, the empirical model that you have built. The advantage of such approach is since you are plugging in the raw input data, right? You already have the output available from real world, right? So you take the input part of it, you plug it into the model. The model churns out some output. You can compare that output with the actual output that you got, right? And that's one way of validating the model. How good is the model? Therefore, trace-driven simulations work that way very well, right?
Sir, if I can ask a follow-up here, because the doubt is on this. So can we compare trace-driven simulation to, let's say, as a modeling exercise? It's just the input data for a model. That is all, right? So in a sense, it is the same.
Yes.
So if I take a logistic regression, which we'll be discussing, the input data for a logistic regression is basically the trace-driven simulation. Is that correct?
Okay, for a logistic regression, see, for all the regression models, we use the anyway raw data, right? We don't fit any distribution and then plug in the data, right? So for a simple model like regression, we cannot explain the importance of trace-driven simulation, right? But let us take let us take a proper business simulation, right? Let us take simulation of a queue, right? You are waiting in your college canteen to get your food, right? That there is a queue. So what is the input data required? Input data required is the distribution of arrivals, as and when you and your friends are joining the queue, and how quickly are you getting served, which means the service time. There are two ways of so these are the two data streams that you will need. you are going to go collect data about it. You are going to collect actual recordings of people arriving and joining the queue, and then you will have data about people departing, the departure data, right? From there, you are going to build estimates of service time. Now, what is trace-driven simulation? Trace-driven simulation is, let us say you actually send somebody, right, and clock them and gather the data for 100 arrivals. You don't build any distribution on top of this arrival data. You directly plug in this 100 observations into your queuing model, right? This is the raw data plugged into the model. What you get as the output from the model, from the queuing model, should match what you actually observed in the field, right? Only then you can say that the model is good enough. Otherwise, the model has done, you may have made some coding mistake. You may have made some logical mistake, right? So that is what I mean by trace-driven simulation.
Sir, so here, when we, why do we use the term simulation? Because it's actual data that is collected. So what is being simulated?
Simulation is, okay, you can observe what happened to this 100 observations. What if you want to understand the general behavior of the queue, right? You're not happy. No statistician should be happy with collecting 100 observations, right? Now you want to say that what if I had 1,000 customers walking in and getting the service? What will happen to my system, right? The queuing system. If I want to analyze that, I have data for only 100. So what are my options? I enter the raw 100 values into the system and say, okay, system is performing whatever it is performing. The other way to do that is using these 100 observations that I have, I build a distribution. Don't enter the 100 values in the model, enter the distribution that I have tried to fit to the data into my model. Now the distribution itself could be of two types. My 100 observations could perfectly fit a theoretical distribution, exponential or Poisson or something like that. Then I don't use the raw 100 values. I actually use the exponential distribution that is built from the 100 values. And what do I mean by exponential distribution that is built from the 100 values? From the 100 values, we are going to discuss that, right? They would have already done that in
Yes,
First of all, I have to really convince myself that exponential distribution is a good fit. Even if I convince myself exponential distribution works well, I have to still estimate the parameters of the distribution. This lambda parameter of the exponential distribution will have to come from the 100 observations, right? So that is me trying to fit a theoretical distribution called exponential. Sometimes the data is so weird that it doesn't fit any of the theoretical distribution. What do? You build your own distributions. Those distributions are called empirical distributions. Empirical distributions are purely built from 100 values that you have collected, right? So you build your density functions from the data directly. It may not be exponential. It may not be nothing. It may be, it is your own distribution. And you plug in that empirical distribution as an input to the to the model. And what does this empirical distribution do, or what does the theoretical distribution do? They generate random variables that become input to the model, right? So instead of using 100 raw arrival times, you are letting this empirical distribution generate an arrival time and throw it into the queuing system. What you get as the output is the simulated output.
Super, sir. I don't know if the person who asked the question in discourse is here. So in case if you are here, you can confirm if your question is answered. If not, please look at the recording. I've tried to ask questions from your perspective so that it covers. In case if you have any queries, post it in Discord and I'll answer it there. Thank you, sir.
Thanks.
Okay, and one more question. I was going through Bayes' theorem and linear remark response curve videos. So I was wondering the rigor of questions that may pop up. Thank you, sir. Okay, I believe that's an observation.
Okay, thanks, Shashi.
Okay. In case if you have any questions, do let us know.
You were wondering the rigor of questions that may pop up. Pop up where? Pop up in the assignments, pop up in the quiz? I mean, we have tried to keep the surprises to the minimum. There won't be any surprises, right? I mean, if you understand the contents of the sessions well, you will be able to do the assignments well, you will be able to do the quiz well. However, the objective of the course is not to prepare you for assignment and quizzes. The purpose of the course is to prepare you for real life. So don't worry. In real life, Howsoever prepared you go in, you are going to get surprised.
And the quizzes will usually give you a business perspective and ask you to solve for that given business perspective. That is how the quizzes are designed. So, yeah, the math trigger is basically application of the formula, choosing the right formula, applying it, or transforming the data that is in the required fashion. Then you apply the formula, something of that sort. Okay, so sir, I believe this will be a good point for me to take over and talk to them about goodness of it. Can I go ahead, sir?
Sure, please, please.
So,
You have the con.
thank you, sir. Okay. Since there were a lot of questions uh, regarding how BA is different from SAS codes, this second week is a beautiful place where it can be explained. So let's take your statistics. You have heard of goodness of fit, right? Chi-square goodness of fit test. Yes.
Yes, yes.
Okay. So what do you do in this? You basically have a table which is going to tell you a bucket, a range, or a bucket, and then you are going to have the observed frequency. So you are given a scenario where you have ranges, let's say 1 to 2, 2 to 3, 3 to 4 if it's a content distribution, and let's say 4 to 5, for example. And for these ranges, you have values here. Let's say you would take AX1, AX2, AX3, and X4, some numbers, right? So this is what you are given in your statistics course, and you are asked to find out whether this distribution of your sample is following some specified distribution which has an expected frequency of, let's say, let us call it E1, E2, E3, and E4. This is done in your statistics. For this, you compute the chi-square and then do your hypothesis test and say whether the hypothesized distribution is truly the population from which the data is coming or not. That is your chi-square test. Now let's take a step back from this. This is statistics. But in actual business problems, what do you get? You get a list of numbers. Let's say I am measuring the length of a scratch on a car that I produce. So what will I get? I will get a list of numbers. Let's N1, N2, N3, up to N. So I have N data points, and each is telling me the length of the scratch. It could be M. Now, going back to our discussion, we want to see what is the, let's say, how good my manufacturing process is. So, given a length of scratch, let's say I have data linking to whether it was defective or not. That is the final data. But that is done if after testing. Before testing, I can directly tell the length of scratches that I have. So given the length of scratch, I want to know whether the guy will become defective or not defective. Okay, so that is the problem. For this, I can't keep going and measuring every time. I have to see for my process what is the length of scratch and whether that, if that is truly my population parameters, will I produce a defect or not? Okay, so like a process control. In this scenario, I have to convert this data to this because only then I can simulate values as input for my process. Correct? I want to do a model which is going to predict defective or not defective, for which I need data, and that data I have to simulate. For that simulation, I need a distribution of the length of scratches, and to determine the length of scratches, whether it's a particular distribution, I need the goodness of fit test. Am I making sense? The link between a statistical technique and the business problem. Is it clear? Any questions so far?
Got it.
All right. Okay. So now the challenge is converting this to this. Correct? So that is what we have. And here is where we are going to use some tool. Let's say we are giving you examples in Python, the codes. So to convert this data into ranges, the observed frequency and expected frequency is what we have to do. To do that, what we need? I need to determine these buckets. Here there are two approaches. Okay. And I will take the example of a normal distribution. You can apply it for any other distribution that you do as an example. So, what is a normal distribution? It is basically a bell curve that is centered on a wheel. Correct? So, this is a normal distribution. And in this, then that will be my buckets. So, if I have to mention my buckets, should I mention it on the x-axis or y-axis?
X-axis.
So I must mention my buckets on my x-axis. This is going to be the length of scratch. Then what is this going to be? The y-axis.
The values of
Frequency.
Is going to be the frequency, the count. It is the frequency or the count. So what am I basically doing? If I split this, let's say between this is 0 to 1, 1 to 2, 2 to 3, the mean is, let's say, is 4, then you have 5, 6, 7, 8, for example, right? So the length of scratch is between 0 to 1 mm. I will find the number of points that are lying here. So that area will basically give me the number of points that are lying. And this is what, if I assume that my distribution is 4 with some sigma, then the number of expected cars that I will have scratches between 0 to 1 mm is this red slash. Okay. So that is using this technique, I am going to get the expected frequency. And x1 is directly going to come from my data. I will count it from there and put it. Now here is the catch. I have two approaches of doing this. I could either consider an even split across my scratch length. So every bucket is now 1 mm long. So all of these are 1 mm long. So what will happen? These red shaded areas will each have a different count. E1, E2, E3, right? So the count in each of those buckets will be different, but the length of scratches, my bucket length, is going to be same. So this is one approach by which I can generate this table. I keep my bucket length same, but my expected frequency is going to vary. A second approach that I can do is I will have the same normal distribution. Okay? It is going to be the center with the same gain, and it's going to have the same sigma. But now what I will do is I will cut these distributions in such a way that everything has the same expected frequency. So now what will happen? This length will be different. Let me call it, what did I use here? 1 to 2, okay. Then let me call this some L1 to L2, L3, L4, L5, and L6. So these lengths are now not going to be same. Okay? So this is the second way that I can develop my frequency table. I can have bucket. These will be of different lengths, so on and so forth. The observed frequency in them obviously is going to be different. So these are going to be different numbers. But my expected frequency in all of them is going to be the same. Whether it is the nth bucket or the first bucket or the second bucket. This is another way to generate the same frequency table for doing the same chi-square test. Okay? And by doing this, if you finally arrive at a conclusion, and the conclusion can be what? There are two options. What would be the conclusion? Of a statistical test? What would be the final conclusion?
Either you accept or reject.
Either it's a good
You
fit
either
or
reject
it is not
or do not reject.
following a standard
Yeah.
number.
So you either reject, it's not. Please not say accept, it's not. It's never that. It's do not reject, it's not. All right. So that is the statistical term. So at the end of any hypothesis test, you are either going to reject the null hypothesis or do not reject the null hypothesis. And whether you use this frequency table to do it or you use this frequency table to do it, let's call this table 1 and this is table 2. So either you use table 1 or table 2, the conclusion that you arrive from both will be the same. The chi-squared value for 1 and the chi-squared value for 2 will not be the same. They will be different. Okay? But the conclusion that you arrive will be the same. Now, this is the difference between what you did statistically, where you got the frequency table. Now, when you apply it to a business problem to fit a distribution, you do that fitting because you want to generate more data for your model. When you are doing that fit, you must see how good the fit is. To see how good the fit is, you need GOF test. And for the GOF test, to generate the table, you have two approaches. Okay? Is this clear so far? Any questions?
Sorry, I didn't get the difference between T1 and T2.
Pardon me?
I didn't understand the difference between T1 and T2.
In table 1, the buckets are of same length. They are all 1 mm. But the expected frequency in each of them is different. In table 2, the buckets are of different length. But the expected frequency in anything is the same. The area under the curve in every bucket is the same. That is the difference.
Okay. Okay. Sure. Okay.
Okay.
Thanks.
Fantastic.
So, one question. This could be true for any distribution.
Any
Not
distribution.
necessarily any. Okay. Even
Yes.
empirical.
Even empirical, yes. It's only the area under the curve. No?
Yes, sir.
The expected frequency is always the area under the curve.
Hmm.
So if you are splitting it in such a fashion that the area under the curve is same, it should
Then
be
it can
the-
fit any. Yes, sir.
Yeah, it can fit for any distribution. This is just an example because it's very easy to understand.
Yes, sir. Thank you.
Any other questions? All right. So now, when you do all of this, we have discussed this in our tutorials. One thing that we have not done, and you will encounter this when you solve your assignment, is an error. Because you will do all of these things in Python, and you will get this thing. An error that will pop up will say the sum, let's call this sum 1, sum of observed frequency and sum of expected frequency are not the same. This is an error that will pop up. It will be there in your assignment. I'm giving you a heads up. I have explained this in detail in the discourse. I would like you to go there and check it out. Okay? For this error, there is a fix and there is a proper statistical solution. I have given both of this in the discourse of the previous term. I want you guys to go read it, then implement that for your solution and answer your assignments when it's being released. Okay? It will come in the 4th week. The assignment will be launched in your 4th week. So you have 2 weeks it's time to solve this. All right? So that's your homework. So you will run into this error and you will have a solution for this. There is a fix. I have told you the difference. What is the fix and what is the proper statistical way to handle this? Both are told. I want you to use this term. Previous term, everyone's used the fix. This term, we'll be giving answers for solutions that come with the proper method that is mentioned. Okay? All right. So this is what I had for today. Any other questions from week 1 or week 2?
There's one question from my end with respect to the same goodness of fit topic. So I remember from one of your sessions, you while going through the Colab notebook, there was a data set wherein we were trying to compare the calculated statistic with the tabulated from the chi-square test itself. So can you give a little more background around it?
So that comes over here. So once you got the observed and expected, you will calculate the chi-square computed value. Basically, summation over I is equal to 1 to, let's call this n, not to confuse with our original n. Let's call this, there are n buckets, right? For every bucket, you will calculate the chi-square as the observed frequency at I minus the expected frequency at I by the expected frequency at I, the whole squared. Okay, observed minus expected, the whole. Okay, okay. I think I am making a mistake here. The square is only for difference. Sir, am I right? Observe minus expected.
The square is only for the numerator.
Only
Yes.
for the numerator. Yes, sir. Right. So it is observed minus expected the whole square by the observed. If you do this, you will get the chi-square value. This is called the computed value. For this computed value, you have computed one value, you want to compare it with something and arrive at the conclusion. So the comparison value is basically the tabulated value of chi-square at alpha m minus k minus 1. Okay, where m is the number of buckets. Let me put this as p because that is what we use in the videos. P is the number of parameters of your hypothesized distribution minus 1. So if it's a normal, you compute the mean and standard deviation or the variance, right? So that is 2. Whereas if it's a pointer, you do only lambda. So that will vary from distribution to distribution. So that you will do. This will give you the chi-square tabulated value. So if your chi-square computed is greater than your chi-square alpha at m minus p minus 1, then you will reject H naught. If not, you will not reject the H naught. Okay? So that is the link between this, the chi-square tabulated, and your final conclusion.
Just one thing, if I may. On the tabulated formula, you mentioned the degree of freedom, which is m minus p minus 1, and then the alpha. So, which is, I believe, the significance level. So, if I have to do it on pen and paper, if you can give a short example, because I remember it was put into
You can't
one
get
board.
this. You can't get this from pen and paper. You will have to get it from the
Okay.
table. So let me just you have a soft copy. Just 1 second. Right. So this is a chi-square, right? So this is my cutoff value. Let's say I take m minus p minus 1 is 6, and I take a 0.05, right? 0.0. Then it is 12.5. So if my chi-square computed value is greater than 12.59, I will reject my null hypothesis. If not, I will not reject my null hypothesis. This value you cannot compute by hand.
Okay. So, we have to refer this table by
You have to refer
combining
it.
those two numbers. Okay.
Of course, since you are using software for most of this, you can do it in the software itself. That itself, if you give the alpha and this thing rho degrees of freedom, it will automatically tell you the value with much more precision.
So there we looked at significance level of 5%, I believe. So 1 minus 0.05 we get in that formula. So,
Yeah, 0.05.
but here we'll directly take the 0.05.
Yeah, you directly take the 0.05. Because
No, so
0.05,
the reason why I'm saying is because in that formula, which we used in Python, we did 1 minus 0.05, comma,
95% confidence. Yeah.
Yes.
95% confidence.
Thank you.
Okay, no problem. Okay. Question on pie charts. Why pie charts should be avoided and what conditions should be used by? Kindly explain with an example if possible. Sir, can I take it?
Yeah, take it.
Right. Okay. So pie chart, the The primary purpose of a pie chart is to show you, how can I put it, splits, percentages, that is the shares maybe. Percentage of the total occupied by something. That is your purpose of a pie chart in a nutshell. So an example, uh, let's say you're producing a product, okay? Uh, and in a month you had produced 100 units, okay? Total is 100 units. Out of these 100, let's say 20 were defective. If I want to show a split between non-defective and defective products, I will use a pie chart, which will basically be a pie, 20%, right? How do I draw this? Okay. So this is 20, this is 80%. And the entire thing is 100. So this will be defective, this will be not defective. And this is the where you will use a pie chart. Whenever I want to show percentage splits, not if we have to show this contribution of each component, then we go for pie. But pie is recommended. Yeah, pie is recommended only when 2 or 3 classes. When you have many, the problem is, let's say I do something like this. The purpose is lost. If I do something of this sort, it becomes very crampy, congested, and the purpose of the visual is lost. So I do not do that. Usually, when you have more than 3 classes, you will represent the dominant 3 and then put all the others in others. That is how a pie chart is used. Because the focus is always on the dominating people. Okay? Sir, have I missed something or?
No, I think all right.
So that is the purpose of the pie chart. Any other questions from any of the other weeks? Week 1 or week 2?
So I have a question not pertaining to the lectures though, but the format would be we will have a practice session every week, is it? Or would there be any graded?
I'm not able to hear you echoing.
So we will have a practice session every week. Will there be any graded assignments as well?
There are no grade assignments for this course. You will be
Okay.
given a practice assignment after every week. Solve that to have an understanding of the concepts of that particular week. You have 4 terms before you that are completed. So you should have access to those QTs as well. So that should be able to prepare you for the quiz 1.
Okay.
And every week our session will be like this. I will usually come prepared with one topic from that session. Usually the topic that is most challenging or students who have asked us before. Based on that, I will prepare and come. Sir will join with Sir is free based on his schedule. And we will be having sessions like this. So the more questions that you ask, the more answers you will get from us. That is how it works.
Yeah, so thank you. Actually, this week we didn't know the session was today, so we haven't been through week 2 actually. But
No,
now that we know, and if we'll know the schedule, then we'll also prepare or we'll go through the content before we come for the session. So it is of help to us.
Sure. So usually, as of now, we have fixed it Tuesdays 8:30 to 9:30. Let me just talk with the team. As sir said, we do have, if we'll try to avoid the clashes. If we can, we'll move around. The calendar should be updated. Uh, yeah, that is what I'll try my best to avoid any crashes. Let me see the numbers and get back to you.
Thank you, sir.
Yes, Subramanian.
So how are we getting assessed, evaluated?
You are assessed. Okay. The course evaluation is basically as follows. You have two quizzes, quiz 1 and quiz 2. Each of these is for 20 marks, and the final quiz score is 0.7 into max of quiz 1, quiz 2 plus 0.3 into min of quiz 1, quiz 2. This will go in for your 20 marks as your quiz component. All right. Then
Okay.
you will have 3 assignments, A1, A2, A3, each for 20 marks, and your final assignment would be for 40 marks, which is best of A1, A2, or A3. So sum of these two is 60 as of now, right? So 60 marks
So
is
the
completed.
assignment 4 is a derived mark, is it?
There is no assignment 4, only 3 assignments. Oh, this
Okay.
one, A5.
Okay.
Assignment 4 is the best 2 out of 3 assignments that you have.
Yeah. So for completeness sake, just say best 2 of A1, A2, A3.
Best of A1.
Yeah. So
Okay. So there is no separate assignment 4.
no
is it?
separate assignment 4, only 3. We will take the best 2. Best 2 in the sense best for you 2.
Let's say someone scored,
So all these practice assignments, how do you really use it?
that is for your practice to prepare for the quiz.
Okay. Do you
So
really
let's
give a
say
weightage to the
someone-
participation? Do you give
Pardon
any
me?
weightage to the participation? Do you give any weightage to the participation? Are you tracking
The
the level of
bonus marks-
participation?
Yeah, the bonus marks is what you're asking for. That is usually done by the support team. We do not have any control over it. If a component exists, they will compute it in the back end. So that they will only have clarity on.
How does it work? Is it based on number of questions people are asking?
No, not necessarily. It is the number of sessions that you join, how
Okay.
you are impacting in the discourse. There are a lot of parameters that they consider.
Yeah, I think if we get some transparency on that basis, it will be helpful for us.
I think you should ask that support team for that.
Yeah.
Okay.
If you have any business analytics related question, this is the session to get it answered.
Okay.
Okay,
Thank you,
Shashi
sir.
has a question about assignments addressing the business problems. Give a data set, all of that. We will give you a data set, and we will ask you some questions on it. There is already an output, and we will ask you questions on it. All kinds of things relevant to the topics that are covered in that assignment. Nothing
So when is
outside
the
of what
likely
was
time for these assignments?
Assignment 1 is in week 4. Assignment 2, you should get it in the grading document. I don't remember exactly when this is. I think this is 5 or 6. Yeah, and this is in 8. I don't remember
Okay.
exactly. It will be available in your grading document.
All right. Thanks, sir.
Okay, and the remaining 40% comes from?
Comes in the final, your final quiz, your end term quiz, that will be set for 45 marks, and it will be capped at 40. What do I mean by this? You can answer for all 45 marks, and let's say someone scores 42, then his end term score is 40. If someone scores 38, their score is 38. That is how it works. So that is your end term. So this plus your end term, which is for 40, you will get 100.
Okay, Ravikant has a question about PA1 question 6 doesn't seem to have the chart name.
Yes, I have raised this to the support team. It is for a pie chart. I have also given the answer to this in your discourse. Just go have a look, okay? I think
And
for
thanks,
clarity, missing.
yeah, and thanks Vinay for clarifying that grading document is fairly clear. Thanks.
Actually, regarding the graded, the document for the grading pattern, for quiz 1, quiz 2, it says 60% and 40%. And here you mentioned 70 and 30. Yeah, that is as per grading document.
60-40. I think
Yeah.
that's an old document. I'll just have a look. We said 70-30. Maybe for some reason they have made it 60-40. But yeah, that is the split.
So 70-30 is a split.
Let me check and get back. I'll get back
Okay.
to you by the next session.
Yes,
I
sure.
have told them 70-30. I believe they have changed it to 60-40 for some reason, or they missed the change.
Okay, okay, sir. Sure, thank you.
The most important thing for out of to be eligible to write the end term, you must have attempted either quiz 1 or quiz 2, one of them, and you should have got a score for A1 or A2. If you don't take any of these assignments, or if you don't take any of the 2 quizzes, you will not be eligible for the end-term exam, which means you will not be given a post grade. So that is that. And of course, there is always a minimum pass mark. For the end-term exam, you should score at least 10 out of 45 to be eligible for a post grade. Okay, so this is in the grading document, which should be fairly clear.
Sir,
Yeah.
again in the grading document it says for attending the final examination, 1 out of the first 2 assignments. That's the only criteria they have mentioned. So maybe you would want to then cross-check.
All right, okay. I believe they have not updated the grading document. I'll go have a word with them.
Yeah,
Thank
sure.
you.
Thank you.
Okay. Yes, Subramanian. Subramanian, please your hand. You have a question? You are on mute. Anyone else? Any other questions? Okay. So I believe there are no more questions. Can we wind up the session, sir?
Yeah, let us.
Okay. Thanks, everyone. Just check the calendar. In case you have not got it, put it in this course. Use a single thread, please. Do not create multiple threads. If someone posts, have a look, then create a new post. One more request from my end. In case there are any errors in PS, please check the previous term discourse. Someone would have already raised it. We would have given a solution. Because of a transfer from term, the correction might not have reflected. So just have a look. The same thing applies if you are solving any of the previous quiz papers. If there was any correction in the previous quiz paper, that would have been discussed in detail in the discourse. So search it before posting something new. This request is being placed because if you continuously post the same answers, it will crowd up our space and we will not be able to answer all of them. That is the problem that we face. Okay, so that is the request from our end. Okay, so if there are nothing else, we can wind up.
Okay. Thank you all for joining. Thanks, Dr. Malalan, for coordinating. Thank you.
Thank you, sir. Thank you, sir, for joining.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Thank you, sir.